In this video, I'd like to talk about the math question of the day for February 22nd, 2023. And we're given two functions, f and g, and we need to find the indicated composition, this f of g of x. And just as a small hint, this is often written as f of g of x, where g of x is actually placed inside the input of f of x. But we're given these two functions, and we need to find the composition of the two functions. So to answer a question like this, you need to have a very solid understanding of algebra, but most likely you will see this in a pre-calculus class. So go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, we can start working through it. And if you do have suggestions for future questions of the day, feel free to leave those suggestions as a comment down below. Now, when dealing with composite functions, personally, I find this second notation a little bit easier, but they mean the same thing. In fact, if we switch this, if we write g of f of x, we could also rewrite this as g of f of x, where instead of this notation, we put f of x actually inside the input of the function g. And this second notation is just, in my opinion, a little bit more intuitive, since you don't have to know what this little circle means. But this little circle just means we're taking a composition of these functions. We're plugging one function into the other. So in our case, we need the opposite of this. We need f of g of x. So we will start with g of x, and we will plug it into our function f. So let's substitute g of x for its actual function. This is 4 over 5x. We are essentially taking one function and just plugging it into another function anywhere we see the independent variable, since that's how functions work. If we had f of 3, we would replace x with 3. We get 7 over 3 plus 4, which is 1. But now instead of actually plugging in a real number, we're going to plug in an entire function. But it's perfectly valid. So we plug 4 over 5x in for x here. We get 7 over 4 over 5x plus 4. And just as a way to keep everything organized, I do recommend plugging your substitutions in inside parentheses. That will just save you trouble when dealing with negative numbers. Though, of course, in this problem, it doesn't actually matter. So rewriting this just a little bit neater, we have 7 over 4 over 5x plus 4. And if we want, since this is a complex fraction, we can rewrite this, though technically this is the correct answer at this point. And one way to check this is to plot some random point. So just plug in some value of x, plug it into g of x, whatever that is, plug that number into f of x, and it will give us some output. If we get some value here, it should be the same as the value we would get here by plugging it into our composite function. So if that was confusing, let me just quickly go through that. Let's say we plug in some nice value that's not 0, since we don't want to plug in 0 in this denominator. Let's plug in 1/5, since that would just make this denominator 5 times 5/5, which is 1. So we get 4 over 1, which is 4, and we're plugging our value of g into this function f. That's what this composite function notation means. And f of 4 would just be 7 over 4 plus 4, which is 8. So if we plug in 1/5 to our composite function, we should also get back 7/8. And let's quickly test that. We have f of g of 1/5. And we get 7 over 4 divided by 5 times a fifth, which is just 1. So we get 4 over 1 plus 4. But you can see this is still 7/8. So we can feel confident that this is in fact correct, since when we plugged in numbers individually, we got the same answer as plugging in that x value to our composite function. So that's one way to check. Though, like I mentioned, we can also manipulate this a little bit and make it look a bit nicer. So if we have 7 over 4 over 5x plus 4, let's get rid of this complex fraction. We can multiply top and bottom by this numerator, or excuse me, this denominator in the denominator. And by doing so, we get 35x up top. The 5x will cancel with this first fraction, so we just get 4, and we get 4 times 5x, which would be 20x. So this is just a slightly nicer way to express that exact same function. But again, if you plug in 1/5 to this, let's set x equal to 1/5. We'll get back the same answer if we do this correctly. We get 35 times by 1/5, that is 7. And 4 plus 20 times by 1/5, 20 times by 5 is 4, so we get 4 plus 4, which again is 7/8. So everything still makes sense, but rewriting it in this form just avoids having x in this denominator here.